Hi there, Charger fam. This is Mrs. Boyd, and today we're beginning a pretty lengthy foray into graphing systems of equations. If you are a line graphing fool, if you're a line graphing aholic, this is going to be the lesson for you. First, let's define what a system is. A system is two or more equations. These equations just so happen to relate to the same incidence. The solution of a system is the ordered pair or pairs that all equations in the system have in common. So in other words, if it's an x and a y, because it's an ordered pair, if you plug that x and y into any of the equations in the system, it will be a true solution. This table, I don't care about. So skip it, leave it blank. We're solely going to worry about graphing these puppies. All right, let's do this first set, this first system. These are in y equals mx plus b form. So first, let's look at this first equation, the red one here. Y equals x plus 1. So 1's our y-intercept. We put a dot on the 1. And our slope is in front of x. It's an imaginary 1. So we go up 1, right 1 as our slope, or down 1, left 1. Connect those points. And there's our line. Now, to make this a system, we put two equations on one graph. So here's going to be an orange line. The y-intercept is -3, so we go down 3. And the slope's -1. Up 1, left 1, up 1, left 1, or down 1, right 1. Connect these dots. And we've done it. You can see that these lines have a point in common, and it's that guy right there. So we can say these lines are intersecting. It means they cross once. They have one solution, and that solution is at -2, -1. I don't care about these down here. So this is one solution. Let's graph this next system of equations. Yellow line will be on top. The y-intercept is 5. 1, 2, 3, 4, 5. And the slope's -2, down 2, right 1. Something like that. Then we have a green line next. Well, this one we have to rearrange just a little bit. We can subtract that 2x from each side and get y is -2x plus 5, which looks really familiar. So our graph of the green line would be exactly on top of the yellow line. That means these lines are the same. When we talk about their solution, they're the same lines. They lie one on top of the other one. That means they touch everywhere. So our solution is infinitely many. So this has an infinite number of solutions. Last but not least, let's do this last group, this last system. I'm going to rewrite this equation, y equals -3x plus 4. I just rearranged it a little bit. So we go up to 4, down 3, right 1. I'm the worst line drawer. We'll have a blue line. We got to rearrange it as well. So y is -3x minus 2. Go down to -2, and then we go down 3, right 1. I don't know if you've noticed, but these two lines have the same slope, which means these are parallel lines. This solution is no solution because they will never ever cross. So this has 0 solutions. So in short, there's 3 possibilities for your systems to have. They can have one solution where the lines cross. They can have infinite solutions because they're the same line, or they can have no solution because they're parallel. Those are the only 3 possibilities. Nothing else exists. So now that you know what the possibilities are, let's do some more practice. We want to graph each system and determine the solution. I will do the first one, and then you're going to be in charge of recreating those on your own. Okay, so we have y equals negative x plus 3. It's our first equation. You go up 3, and then the slope's -1. So down 1, right 1, down 1, right 1. There we go. Let's rearrange the second equation. We'll subtract x from each side, and we get y equals negative x plus 3. Oh, here we go. Negative x plus 3 on the top, negative x plus 3 on the bottom. Those are the same line. So their solution is an infinite number of solutions. Really, don't write that. I mean, I guess you can, but really the correct solution, we would write infinitely many. Let's do another one. You try this one. I forgot I said that. You're on your own. Come back and check your work. We can add a plus 0 on the end here. So our y-intercept is 0, and the slope is 2. So up 2, right 1. Something like that. And then we have y equals negative x plus 3. So we go up 3 to the y-intercept of 3, and down 1, right 1. Looks like these are intersecting lines, and they have one solution. And it's going to be at point 1, 1, 2. So at point 1, 2 is our solution. All right, try the next one. First, we've got negative 5. 1, 2, 3, 4, 5 down on the y-axis. And then the slope's -1. Left 1, or nope, from here, up 1, left 1. Can't go down. Looking like that a little bit. And then we've got y equals 4/5 x plus 4. So we go up to the 4 on the y-axis and down 4. 1, 2, 3, 4, right 5. 1, 2, 3, 4, 5. Oh, that's what I did wrong. Sorry, I was thinking really hard. Did you notice? My second point is wrong. Sorry about that. I'm going to go down 4 and left 5. I can't go up. That's what had me all confusion. Sorry about that. So our solution is at -5, 0, where these two cross. Whew, man, my brain. 3 more. Try the next one on your own. Let's see if I can figure it out. Goodness, my brain can't keep up. All right. We need to get y alone. I'm going to write it down here at the bottom. So I'll subtract 2x and get y equals negative 2x minus 4. So we go down 4, and then negative 2 for the slope. So up 2, left 1. That's one equation graphed. Second one, negative 2x plus 4. So we go up 4, and then negative down 2, right 1. We can look at the equation and see the slopes are the same here. So this will have no solution. These are parallel lines. Next one. All right, y equals 3/5 x minus 4. So we go down 4. 1, 2, 3, 4. And then up 3, right 5. Well, that line made no sense. There we go. Next one, y equals negative 4. That means it's going to be a horizontal line at y equals negative 4. We do have indeed one solution, and it is at 0, negative 4, where these two lines cross. Last equations, last system, you're up. Do it. All right, first one, y equals 4. So we go up 4 and horizontal line. Remember, y equals 4 no matter what x is. Y is always 4. We can graph those 3 points and get the equation graphed. Then we have x equals negative 2. No matter what y is, x is always negative 2. It means go left 2, and we've got a vertical line at x equals negative 2. This has one solution, and it's at negative 2, 4. Put those two parts of those two equations together in the x and y spots, and we get our solution. All right, kids, I hope you're feeling pretty confident about this. I hope your graphing skills have increased. Please reach out if you have any questions or concerns. See ya.